Hello everyone, and welcome to the first edition of the Chaos Week. We will wait for about 2 to 3 minutes to let all the attendees join and make themselves comfortable. I hope also that you have seen the previous talks. They were very interesting. I invite you all to see them. They were in the WeScale TV. They are already recorded. Yes, we will wait for 2, as I said, to 3 minutes. En français, bonjour tout le monde. Je vous remercie d'être venu à la première édition du Chaos Week. On va attendre à peu près de 2 à 3 minutes. J'espère que vous avez déjà vu les différentes sessions les conférences précédentes qui sont autour du Chaos Engineering, Kubernetes et AWS. Et ils sont déjà enregistrés dans le channel YouTube du WeScale TV, dans un playlist Chaos Week. So I think that we can start our talk. So welcome again. I'm Akram Riai, Litmus Chaos leader and cloud builder at WeScale. I would like to thank you all for attending this talk of the fourth day of the Chaos Week. I invite you also to take a look on the previous talks. They were very interesting. You will find them in the WeScale TV channel in the Chaos Week playlist, exactly. So, as you may know all, that chaos engineering is one of the main topics nowadays, and it's also particularly interesting for us at WeScale. For that reason, we wanted to share with you via a free and an online event that lasts for 4 days. Our goal is to make it accessible for you, a vision and of some experts and insight and feedback also on this topic. I would like also to add that the chaos engineering has been integrated as a discipline in many companies' strategies to help for their continuous improvement and in their cloud native transformation strategy. For that reason, I'm very happy to welcome Uma Mukkara, co-founder and CEO of Chaos Native, and one of the maintainers of Litmus Chaos. Uma will be talking today about the evolution of cloud native chaos engineering. Hello, Uma. How are you?
Hi, Akram. Hello, everyone. I'm doing good, Akram. Nice to be here. Thanks for inviting me onto your show.
Yes, it's a pleasure to welcome you for the first edition of the Chaos Week. And I would like also thank you for joining us today. So I will now let you take the lead, and I wish everyone a pleasant conf. I will come back later for the Q&A session. Thank you.
Sure. All right. Hello, everyone. It's a pleasure to be here, and thanks to WeScale for inviting me here. Today in this session, I'm going to talk about a little bit about what is cloud native chaos engineering and how we have used these principles to build Litmus project and what are the latest features of Litmus Chaos technology or project. So before we go in, a little bit about me. I am Uma Mukkara. I have co-created multiple open source projects, the latest one being Litmus. I co-created this project about 3 years ago, along with a few other colleagues, and now it is a CNCE project for about a year now. And on the business side, I'm the CEO of Chaos Native, which is a company that we spun off from MayaData to focus primarily on Litmus. So I live in Bangalore, India. After these times, I would probably be all around the place after this COVID times. But right now, I'm located in India, Bangalore. So with that, the first part that I want to introduce is cloud native chaos engineering. What is it, why is, and how? And the second 20-30 minutes, we'll go a little bit deep into Litmus chaos, right? You might be hearing about what is chaos engineering, why in this week, or you have so much other material available in general. So I'm not going to go very detailed into what is chaos engineering, but I will touch upon what and why, how part of it, right? So what is chaos engineering? You can tell it in many ways. The first one is break things on purpose, right? And that's a simple definition. You're injecting faults willfully into some system that's supposedly working already, right? And you can also say, don't wait for a failure to happen. You cause the failure, right? So that the development side is better prepared for the bugs that are about to come. You can also say it's about proactive resilience engineering, right? So overall, the chaos engineering is about either you are a developer or an SRE or the operations manager or the CIO. Are you better prepared for a fault that can happen, right? So that is what is chaos engineering, right? And why do we need to do that, right? Why do you need to break things on purpose? Is we all know that outages can cause a lot of financial losses depending on the type of outage, right? And no matter how well you're prepared, how smart our team is, outages are inevitable. At some point of time, some form of outage can happen, right? So assume that and then be better prepared, right? And there are so much of changes that are happening in IT environment. I'll talk about them a little later, right? Why do you need to do chaos engineering? Recently, I started telling this that you should do chaos engineering, but because you can, right? Earlier, chaos engineering was only meant for experts, right? It is difficult to go and conceive the whole process of chaos engineering in a way that gives you a very good benefits, and it takes a lot of work. But now with so many tools around there, so much of best practices being available to you, services being available to you, chaos engineering is not very difficult to do. So you should do it because you can, right? How? There is a lot of things about how to do chaos engineering. Primarily, it is a culture thing. It is not a one small piece of work that you need to do. It is a practice, and you need to do it together as a team, right, including your management, right? So you need to have a strategy to do chaos engineering, including the why and what are the outcomes that you're expecting, all that stuff. And typically you start with game days, you start small, and then probably in pre-production, and then you normalize it in staging. Then finally you go into production. Then, like after 2-3 quarters, you are actually going to scale it up, right? So this is how chaos engineering has been practiced so far that we all know of, right? And people may ask, what are the real business benefits of chaos engineering, right? There are two types of benefits. One is about, think negatively, right? Or it's all about, you can put some fear into somebody saying that you have a business benefit of preventing your losses, right? Just prevent your revenue losses or outages or services, retain good customer, credentials or satisfaction. All that are good, and this is what your business can get with the practice of chaos engineering. There are other tangible benefits that have cropped up with this new advocacy of chaos engineering. That's about how do you scale when the demand comes, right? So how can you scale faster? So you don't need to, sometimes, operations are run at 50% overhead, 30% overhead, because when there is a demand for scaling up, you don't know whether we'll have a problem or not if something goes wrong. So you run at a scale more than that's needed. So you can avoid that, right? If you actually practice chaos engineering, you know for sure when there is a demand, you can go and scale it up and things will go fine, right? And also your team can be better prepared, trained, and they are giving good response to an outage, right? So you can reduce the outage time or reduce the mean time to recovery, right? So these are the benefits on the business side for why someone has to practice chaos engineering. Before we go into cloud native and chaos engineering, let's talk about what is reliability and cloud native, the definitions of that, right? Reliability is pretty simple, right? You have to run your services without outage, right? You can call them 4 nines, 5 nines, 6 nines, but it's as simple as they need to run without any outage, no matter what, right? So that's the definition of reliability. And why are we talking about cloud native? What is cloud native, right? So there is a good definition, or the most correct definition is given by CNCF, but I'm going to just talk about cloud native with the current topic in perspective. So I've taken this slide where there is like a good simple definition that you can visualize, right? So what is important for us is we all know the benefits of cloud native, but what is cloud native, or the architecture is about microservices, containers, service mesh, and Kubernetes. If you're talking about cloud native, this is what you're going to see, right? You will see microservices and a lot of container related services or technology, and you will generally see service mesh, and then obviously Kubernetes is a given, right? So in summary, the differentiators are between cloud native and non-cloud native. You will be dealing with a bunch of microservices, and you will be developing your application as a microservice, and you will have a lot of other microservices that you depend on, right? Obviously, it's all about containers. And the main thing that I want to emphasize here is in cloud native, speed matters, right? You're going to cloud native because you want to deliver your application releases faster to your customers, right? Your users. So there is less time to deliver, and that's the reason why you're going to cloud native, right? So if you're doing things faster more often, then what is reliability? How do you define reliability? The perspective of reliability in cloud native, right? So the main objective remains same, right? Run services without an outage, but you keep changing things. So you need to keep measuring your SLOs or business SLAs to make sure that they're okay. And you also need to guarantee reliability when you scale your services on demand, right? So that's another common thing in cloud native, because autoscalers are common, right? When there is a traffic on demand, things should scale. It's distributed application, distributed platform, right? Are you going to be reliable at that time, your services, right? And because they are coming too fast, that really means that you're upgrading many times. So your reliability means that you should not have any outage during upgrades, which happen pretty often, right? So that's the definition of reliability or perspective of reliability in cloud native, right? So let's touch upon a little bit more for saying why do we need cloud native chaos engineering. Let me put it the other way. Why do you need reliability in cloud native, right? We just talked about kind of a business benefits. Let's talk a little bit more about why they happen, right? There are two reasons. One is, your application is broken up into multiple services, right? Multiple containers. So containers are defined as you build something within a container and you can run it anywhere, right? So it's a concise definition of it. So you have multiple microservices to deal with than your single application. And this application depends on other microservices, which are again larger in number, right? And they are coming fast to you. Let's say that you are using a Node.js, and Node.js also is containerized, and the updates to Node.js are coming faster because they are also doing cloud native, right? So, and CI/CD pipelines are helping achieve this dynamism. So, as an advancement of CI/CD tech and containerization, instead of taking a traditional quarter or 2 quarters time for getting the updates of your dependent services, you are really getting changes almost every week, right? So you have to develop faster, and you are getting the underlying changes, dependent microservices changes are also getting faster, right? So there are a lot of dynamism that goes into this cloud native, right? So there are changes that always happen. So how do you define the reliability comfort here, right? When the changes are happening too fast, and there are too many such services, how do you achieve reliability in cloud native, right? So the obvious answer is you have to practice chaos engineering in cloud native, or we can, just say it in another way, you need to practice cloud native based chaos engineering or cloud native chaos engineering. As simple as that, right? So far we just covered what is chaos engineering, what is reliability, and what's cloud native, and why we need cloud native chaos engineering, right? So let's look at what is the main thing that you need to remember when you're talking about chaos engineering in cloud native, right? Remember, we talked about cloud native having too many microservices, right? So things can go wrong in many, many ways. Of course, they are stable. People ship their products or their services, their images after doing enough testing, but we assume that things can break, right? And it's not like a one-time testing. They're getting upgraded most of the time, right? So you need to have chaos experiments, right? Not just for your application, but the other microservices that your application depends on. You should assume that Kubernetes can go wrong, right? Irrespective of the great amount of testing being done, things can go wrong in the platform, right? Because it is software, right? So you need to have this chaos experiments for Kubernetes, right? And your dependent infrastructure, right? You are running in a multi-cloud environment or many clouds environment, as they call recently. You should assume that the micro infrastructure elements can go wrong, can go down, right? So you need to think of having chaos experiments for all these needs. And you need to think of having chaos experiment for your own application, right? So you don't want to be writing chaos experiments for all this stuff, right? In cloud native, you may be wanting to concentrate only on the last thing, where let me write chaos for my application, and can I get chaos experiments for the rest of the things automatically or readily available somewhere, right? So that's the primary requirement that we should expect in cloud native chaos engineering, right? So they also should be Kubernetes native, right? So you're getting your chaos experiments for your application or your other services, but how do I manage them, right? You want to keep them as close to as your other model of software development or management or operations, which means that they need to be declarative and they need to work with your other cloud native tools, right? So that's where we say it's cloud native, right? So you're doing GitOps differently, you're doing metrics management differently, event management differently. For example, metrics Prometheus is common. You want to choose cloud native chaos engineering tools that are integrated into Prometheus, right? Events, Kubernetes events, it should give. So that's what makes your life much easier. And then the lifecycle management of chaos experiments itself. Are you following the same model of lifecycle management as your other applications for chaos experiments as well, right? So these are the basic requirements of chaos engineering in cloud native, right? So to summarize, we have defined before we started even writing, or at the very beginning of started to write Litmus, we have defined certain principles. If we have to build a very large, highly scalable Kubernetes application for chaos engineering, what should the basic principles be, right? So of course, you need to develop them in open source because it's cloud native, right? So cloud native not necessarily mean open source, but most of the stuff is happening open source so that the community can really get to it and then validate it, provide feedback, collaboration happens, right? And community collaboration has to be done for chaos experiments because we believe chaos experiments will become a commodity, right? So just like we mentioned in the previous slides, right, you need to have ready experiments or workflows for your other dependent services. You want to be concentrating on chaos for your own application. So for the rest of the things that those chaos experiments need to be community collaborated, they should be available in some place. That's where we went to Chaos Hub, a concept, right? And for the lifecycle management, we expect the chaos experiment should have an operator model, a good chaos API, so that when you upgrade your chaos experiments, things follow the way other applications follow, right? So the other one is scale up, right? You always start in cloud native small, and on demand you increase, right? You don't change the architecture, you keep throwing up the nodes into the cluster and then or auto scale it, and then your application is scaling. So similarly, your chaos practice also, or chaos engineering also has to scale up, which really means that you have to have the concept of GitOps working well with your chaos engineering as well. So finally, the other principle is open observability, right? Injecting faults itself is a big deal. You need to do them methodically in a way that they are scalable. But when you do inject faults into a scaled system, you need to be able to quickly understand what's going on compared to your other existing monitoring systems, right? So you don't want to create a new observability platform for chaos. Rather, chaos should be imposed or superimposed on your existing monitoring systems, right? So that's where we call open observability. So you should have clearly defined annotations or metrics, chaos metrics for various chaos experiments that you do. Then observability becomes more insightful, more rewarding, and more useful, right? So these are the principles we believe that will help scale chaos engineering and to start up practicing chaos engineering as well. So that's really why and how part of cloud native chaos engineering. Now let's actually go and take a look at an example of a tool set that follows these principles, right? So I would like to introduce the project that we have created, Litmus Chaos. We have created this about 3 years ago. We've been hard at developing. We've been working hard in developing this project for 3 years. Last 2 years have been like we're putting a lot of effort. This is our little mascot, the chaos bird. You might be seeing why they're wearing, the bird is wearing a jacket. It's an SRE doing some experiment as a PhD or as a doctor, right? And then we put in Kubernetes symbol because it's cloud native, right? So, and you can look at litmuschaos.io for more information, but basically it's a tool set to do chaos engineering in a cloud native way. And in the last 1 year, there has been a lot of traction for Litmus. There are a lot of contributors, practitioners, like Vscale has been an adopter of Litmus. They've been contributing to this project, in various ways. And you can see we actually hit a half century in terms of the number of experiments recently, right? So we expect them to go to 100 or more, in the time to come, where the community comes and adds more experiments to this hub. And it's been used significantly in the recent times. You can see the known public installations are about 68,000. About a year ago, we were in the 20,000, right? So first 2 years, we got 20,000, and less than a year, we are getting about close to 50,000 installations. So Litmus is being used. That's good news. On a higher scale, that's good news for us, because we get more feedback, and the stabilization happens, right, faster. So Litmus follows all these principles, and we took some time to develop this project, as it always takes time to listen to the community and get their feedback and get the real usage going, and then do it. But now we are at the last stages of 2.0 beta. I think in a month or two, we should see the general availability of 2.0 going in, right? So it follows all the principles now, and we are pretty thrilled to be at this stage, right? So how did Litmus actually develop, right? And we didn't want to develop a project with all the features and then give it, as a community to use it. Rather, go with the MVP model, minimum viable product, and then keep on adding it, right? So back in 2018 May, we just released a chaos experiment that can be run on its own as a Kubernetes job, right? From there, we then added, wanted to make it a managed experiment, which means that we added a chaos operator, then we added a scheduler to it, and then we want to get multiple experiments to be put together. That's what chaos workflow. Managed chaos workflow is a control plane where multiple team members can manage this workflows. And we added GitOps to make it scalable. We added chaos metrics and open observability to see how things are going on when chaos really happens, right? There's more to our journey, which probably will be talking in the near future. One of the things is how to make it easy for developers, right? So as you can see that this is a mature journey in terms of, it took about more than 2.5 years to get these things done, and they are being used by many large enterprise users right now, which really means that they're vetted, right? So today, as Litmus is a feature complete project, I can say that at the center of Litmus control plane, we have chaos workflows, right? And chaos metrics, which is centralized for observability, centralized metrics storage for observability. And you have this chaos hubs, which are where you can host these experiments. There is a public hosting space, hub.litmuschaos.io. And you can also host in your private Git repositories, which we call private chaos hubs, right? So the development experiments that you developed in private, you can keep them and you can manage them with your own teams. And multiple team members can interact with one Litmus enterprise portal or control plane, and you can attach it to GitOps, right? I'll talk about what is GitOps in a second. And this is what we call as chaos control plane. And chaos execution plane is, once you have the chaos workflow, you can target it to various resources. We started with Kubernetes-based resources or applications, right, or Kubernetes platform itself, but it can also target other public cloud infrastructures like AWS, Google, Azure, or DigitalOcean. Or you can have these targets going after virtual environments like VMware or any other legacy applications or even bare metal, right? So the structure or the architecture of Litmus is suitable when you have this chaos control plane and chaos execution plane separated. Of course, we have very matured state in terms of the chaos experiments for Kubernetes, and the architecture is ready and in force. The implementation for the other chaos experiments, we have beginnings of experiments for all other platforms, including VMware and AWS, Google, for example. Right. So that's basically a kind of a feature complete stuff. And I would like to now go and talk in detail about what is Litmus 2.0, why we call Litmus now as feature complete. So one of the things that we wanted to make sure that we address when we add so many new capabilities into Litmus, we wanted to make sure that it's also easy, right? In terms of ease of use, or ease of observability, or ease of understanding what's going on, or how can you actually go and create a new experiment, right? And how easy it is to scale, right? So we have addressed, there is some feedback we have received that Litmus is great, but you have to have a bit of a learning curve to understand your service account structure. You need to understand, you need to put together experiment YAML, right? So with Litmus 2.0, you got a lot of predefined experiments. You can use button clicks, right? So you take a Helm chart, install, your portal is up, and then you got a lot of ready applications or ready experiments, workflows that you can unleash against certain known targets. And it's so easy to use. Kubernetes users with minimum knowledge should be able to use Litmus 2.0 very easily. At the same time, we made sure that for advanced users or experts, it is still very flexible, right? If you want to build a very complex chaos experiments with a lot of custom code, you can still do it, right? So that granularity to keep the flexibility is still there with 2.0. At the same time, it's easy for a layman usage, right? So what are these features that we have used in Litmus? We have developed in Litmus 2.0, right? The first thing is, let me go through one by one in detail, right? So this is just a summary of all the features that we have put together for 2.0. So the first thing is control plane that can manage the chaos in a multi-cloud environment, right? So you don't want to be installing Litmus on every Kubernetes resource, or how do you actually manage this chaos for a non-Kubernetes targets, right? So you need to have a centralized place where APIs are available. And that's where we created Litmus portal, right? At the same time, the metrics are also aggregated towards one. You can have against multiple as well, but they are all aggregated into a central repository or multiple central repositories, right? So this control plane lets you deal with the concept of chaos workflows and the teaming GitOps all on one side. On the other side, the execution plane is all about, now I have a workflow, what does it do, right? How can I take the metrics and then push them the results and all other stuff, right? So that's the big thing that we have done. So this is what this essentially means is Litmus can be used in large production environments, in enterprise-based environments, very easily in a way that scales and manageable, right? The other one is teaming, right? This is one of the requests that we got, right? So SRE teams work as teams, and developers work as teams. So you need to be able to collaborate your experiments. You need to be able to observe the chaos engineering experiments, right? So we have introduced the concept of a project. Everyone owns a project in Litmus, and they can go and share their chaos workflows, experiments that they developed or they want to use from others. They can all share it in a very easy manner. And you have edit and view controls for each of the projects. You can invite a person as a view only member or as an editor as well, right? So that's basically teaming. There is more to come in this area based on the feedback we get, but it's pretty much feature complete as far as the usage of teaming is concerned, right? The other one is workflow, right? Litmus 1.x is about individual experiments. Now with the 2.0, you can have workflows where multiple experiments are put together, and we chose Argo primarily because it's a mature technology, and Kubernetes users or SREs are already used to deal with Argo workflow when they want to put multiple things together. So we want to give the same comfort or same experience for dealing with chaos experiments when they want to do something manually, right? And one other big advantage that Argo workflow gives is you can run things in parallel, right? So if you want to build a complex chaos scenario, you may want to induce chaos at a time, more than one chaos at a time into various things, and then you want to be able to orchestrate it, right? So Argo workflow helps with that. And on top of using this basic structure of Argo workflow, we have added more logic to consolidate the results in a chaos lens and update the chaos experiment results. So that's what we call chaos workflow. We just don't call it as basic Argo workflow. So it's Argo workflow plus customized for chaos. We call it as chaos workflow. And this really gives the foundation to GitOps, right? You can construct a Argo chaos workflow. You can just throw it into Git, and then you don't need to really have the portal up and running to run the chaos workflow. Only to do some monitoring you might need, right? So with Argo-based chaos workflows, complex scenario definitions are possible, right? If you are, remember after 2-3 quarters, now you are a good practitioner of chaos engineering. At that time, you want to unearth complex bugs, right? So double faults, triple faults, right? So how do you manage all that experimentation? So you need to write a complex workflow. Argo and Litmus workflows, they support that kind of scenario, right? So this is an example of a chaos workflow, a simple chaos workflow rather, where you can see that multiple stages are there, and you can run this chaos experiments in parallel. In this case, I started running a load test. At the same time, I'm doing some chaos injection, and then observing one more pod delete at that time, right, and then see what's going on. You can see the logs, chaos results. So this gives a good observability of what's going on, right? The next, my favorite of Litmus 2.0 is probes, right? So experiments are good, workflows are good, they give a lot of flexibility, but real chaos engineering is to define what is your steady state hypothesis. It means different things to different people. So we cannot go and define, this is the chaos experiment, this is what it does. And this is how it interprets the success or failure, right? You want to give that control to the user of this experiment. And that's what probes will help with, right? So there are many modes for probes. Either you can do a continuous probe or an edge probe. That means front end, back, beginning and end, or only at the start, only at the end, or only during the chaos, right? So you can put together, this diagram explains that you have many ways of plugging things together. You can just go and probe whatever you want. And there are multiple types of probes, and we're going to add more and more types. But basically right now you have more than what you require for your initial chaos engineering in terms of HTTP probe. Command, you can just write any bash script and then introduce that. That gives a lot of script and power. And then there is Kubernetes based probes where you deal with the kubectls and events, all that. And Prometheus based probes, which are very, very powerful to help with SLOs, right? So not only just chaos results, but if you want to do some SLO based chaos engineering, you want to observe, take the decision based on some SLOs, Prometheus probe can help, right? So these are the SLOs. For example, a Prometheus probe is written where a query is considered as a service level indicator or an SLI, and this comparator is used as an SLO, right? And the next feature is GitOps. GitOps, you can really define in the perspective of chaos as two different pieces. One is the front-end GitOps, where you are taking the help of a portal to go and define a complex chaos experiment or workflow, and I want to push that into Git, and not to my local database, but to Git repository. And when somebody changes directly in a Git, I want to be able to see those changes in my portal, right? So that's called front-end GitOps, and it is supported. At the same time, the back-end GitOps, or in general what we call the real GitOps, is about being able to trigger something based on a change that happened in GitOps, trigger a change to an application, right? So maybe there is a change to the application version, so you upgrade the application. That's what a typical GitOps is. But now we are talking about what is GitOps in terms of chaos engineering here. So you want to trigger a chaos workflow against a target based on a change to that application. For example, you are upgrading an application version from 1 to 1.1, right? So you want to be able to test various chaos scenarios because you changed the software. You can just automate all of these things by using the GitOps feature of Litmus. So based on a change, you can control what chaos workflows need to be triggered. And if there is a major upgrade that's coming, you can run a lot of workflows or randomized workflows. If it is a small change, you may want to limit your chaos workflows, etc., right? So the other one is hybrid targets. We have the architecture where you can run on the execution plane, you can run your chaos workflows against non-Kubernetes targets, such as any cloud platforms, as long as the API is open, right? So DigitalOcean or AWS or Google or Azure, or you can run them against VMware. So or bare metal or any other legacy apps. So the whole idea here is you will still go and define the chaos workflow on the Kubernetes-based Litmus, but the agent runs on Kubernetes. The real experiment runs through the network API on the remaining on the remote targets, right? So the API is complete. The API has been there for some time. We have not seen many users using the remote API, but now a lot of users are using Litmus API for using Litmus in CI pipelines, right? So you generally have a central plane and a central portal of Litmus where your workflows can be defined and executed against a pipeline as a target, right? So you can use Litmus agent that is dynamically created inside the pipeline, and then pull the workflows or define the workflows, through Litmus API and then use them, right? So you can browse the Litmus API, but generally once you install, there is a API portal or API available on your local reachable endpoint. So this is observability. There are two types of observability that we are talking about. Litmus 2.0 includes built-in observability feature, right? So for example, you don't have Grafana setup, and you don't have any other advanced monitoring setups such as Dynatrace or Datadog or Splunk or anything, but you want to be able to quickly see what's going on. Litmus provides basic Kubernetes visibility and some demo applications that are interleaved with chaos. So that's given. And also Litmus gives a workflow analytics, right? So how is you don't need to really set them up elsewhere. They're all available in Litmus, right? So what's the difference in terms of the results of this workflow now versus last time, right? So that is one type of observability. The other one is you have a monitoring system. You want to be able to put the perspective of chaos into that, or superimpose chaos understanding onto those dashboards. And that's also possible through annotations and chaos metrics, right? So this is an example that you're seeing. This is a Grafana dashboard. This red things that are superimposed are about chaos intervals that between which you introduce some chaos. So this gives a good idea about okay, what happened here, chaos, and then you can go and see on the CPU dashboard, you can just enable chaos interleaving there, and then you can just observe things with perspective. It helps a lot in defining, in debugging complex scenarios, right? And air gap support, a lot of users are using Litmus in air gapped environments. So it's pretty simple. We've resolved many issues few quarters ago, where now the private images are nicely set up, and you can continue to do chaos engineering in your private network. And one thing that adds to this capability is the private chaos hubs, right? You can get your public repository imported, but you don't want your private Git to be exposed. So you can set up your private Git in your private network and then use them as a private chaos hub in Litmus, and collaborate with your team members. So that feature is also built in, and you can now do end-to-end chaos engineering in your private networks. So that's about it. And I would like to say some more things. Recently we became chaos native from being one of the projects within MayaData to a company who's completely focusing only on Litmus. So we started offering enterprise support packs or professional services or managed services through some partners, and there's more to come, right? So you can take a look at chaosnative.com, which is a new website that we put together a couple of days ago for this KubeCon. And we are definitely taking a very serious approach to help enterprise customers to deal with chaos engineering in cloud native, right? So if there are any questions, or you need some kind of a support, or any other advice or chaos engineering in cloud native, feel free to reach me, or you can also follow through our community and GitHub at this URL. So with that, I would like to stop sharing my screen and then probably take a look at some of the questions.
Thank you, Uma. Thank you very much for the presentation. It was great and instructive. I hope that it was also clear for the attendees. Well, I will take now the question if there is some questions that were posted in the chat panel.
Well, yeah, there is something in French you need to translate, I think.
Well, I don't know. Oh, nope. There is no question. But well, I think that was clear. That's why. But I have some question.
Mm-hmm.
Uma, do you think that that chaos engineering is only for? Here we have talked about cloud native and some mature applications deployment. So do you think that chaos engineering is only for mature products and teams?
Not necessarily. So that's the big difference in the modern chaos engineering, right? So we are advocating, and I've seen a lot of other chaos experts are also advocating something called chaos first, right? So no matter what, how you're going to go big or small, you need to start with chaos engineering as a good practice from the beginning, right? In fact, you can go all the way to doing a simple development. You write your Kubernetes resource, you add a failure testing, like your integration. You can add a chaos testing also to the mix, right? You can start introducing chaos right in the pipelines, right? And then you're doing, Kubernetes upgrades are supposedly, common. And even for a small setup, you'll be doing Kubernetes upgrades, right? So how do you do some failure testing? Right, so you can consider chaos engineering a simple kubelet kill or pod delete can bring out some issues that you might not be expecting. If everything goes okay, then you're good, right? So that's the whole point of chaos engineering. Try to break things, and it is easy, right? So it's much easier than you would have perceived otherwise in a non-Kubernetes chaos engineering. We at least try to make things are very, very easy for beginning users as well as for the advanced ones. Yeah.
That's great. So after this presentation, we have to make sure that Litmus Chaos 2.0 is very enhanced. It has been very, very enhanced if we compare it with the last version, the previous version, and also with this portal, it's very helpful, and with its integration in the CI and the cloud native applications. So yes, that's all on my side. So.
Great. No, thank you, Akram, for trying out Litmus. You've been helping us with various feedbacks, and you've been running some great meetups in your local area. So thank you for being a champion of Litmus, and really appreciate that. And thank you for having me here.
Thank you, Uma. Thank you.
All right.
Pleasure is mine. Thank you.
Yeah. Have a great day. Cheers, guys.
Thank you. Bye. So, thank you everyone for attending this conference. I would like also to mention that there is another one that will begin in 8 minutes that will be hosted, that will be taken by Karthik. And he's going to talk about chaos engineering and declarative hypothesis. The link is in the chat panel, so you can connect to the talk. Thank you, everyone, and have a great evening.